Herzlich willkommen zur Ringvorlesung wieder in unserer Reihe We Need to Talk About AI. Das ist ein Angebot unserer KI und Wir Convention, die wir schon 2019 gestartet hatten mit Bundesmitteln und jetzt auch mit Landesförderung, gefördert vom Land Sachsen-Anhalt und in Kooperation mit den Landeshochschulen durchführen möchten, um insbesondere uns den Fragen zu stellen, die die Entwicklung von KI und auch möglichst ihrer sozial gerechten, antidiskriminierungsfreien Entwicklung nachgehen. Und da haben wir unterschiedliche Expertinnen und Expertengespräche und eben auch diese Ringvorlesung gestartet, die einmal monatlich mit einer Hochschule zusammenarbeitet und heute auch das erste Mal wieder unter der Moderation von Eva Wolfangel international hier in den Ring geht. Und wir haben jetzt zwei ganz tolle Gäste, die sich um das Thema KI und Medizin, All About Data, heute auseinandersetzen und mit Ihnen auch in den Diskurs gehen wollen. Und wir switchen jetzt auch gleich mit Eva ins Englische. Und ich darf ganz kurz noch vorausschalten, dass es aufgezeichnet wird wieder und für alle, die nicht teilnehmen können, heute auch dann in der Mediathek zur Verfügung steht. Dies vielleicht kurz vorab. Ja, und dann würde ich gerne an dich übergeben, Eva, und freue mich auf den Diskurs mit euch. Herzlichen Dank.
Hello, everybody. Very warm welcome from my side as well. As Ilka already said, we are switching to English now. I'm happy to discuss this important and really interesting topic about AI in medicine and how to make this a fair and ethical, good future for all of us. Maybe just real quick, a few housekeeping things. As Ilka already said, this meeting is being recorded. Nevertheless, we love to see people. So if you don't mind to switch on your cameras, if you are not, if it's okay for you to be on the recording as well. Of course, you don't have to, but it's always nice to see a few faces. We will start with two short introductory talks by our two speakers, and after that we will go into a discussion with all of you as well. So if you have questions after the talk, I would like to ask you to write just your name into the chat. That helps me to call you when it's your turn, and then you can unmute yourself and ask your question. If you don't want to ask the question in person, if you don't want to unmute and don't want to appear on the screen, you can write the question in the chat. However, I prefer to hear you because often it's easier to explain your questions and maybe add some things. Okay, so let me start by introducing our two great speakers. We have today Anika Groß, who is a professor of database systems at Anhalt University of Applied Sciences. And she conducts research in the areas of knowledge representation and the integration and analysis of large heterogeneous data sets from diverse sources, which is a big topic in machine learning and AI and often the source of a problem if this is not done well. She is particularly interested in applying methods from the fields of data science and artificial intelligence in collaboration with colleagues from other disciplines for cross-disciplinary interpretation and use of data in novel applications. A very warm welcome to Anika, and I introduce Abri as well before the talk starts. So welcome to Anika Coertze, who is a biomedical mechatronic engineer and interaction designer specializing in mHealth applications, patient-specific data management, and especially interested in extended reality systems to help improve medical services. He has developed a proof of concept augmented reality system with a Microsoft HoloLens to assess the feasibility of using commercially available XR systems to create the necessary medical devices. Currently, he is a co-founder of a startup in South Africa, which is called Link Health Technology, and he is working at Hochschule Anhalt as a research assistant. Very warm welcome as well, Abri. And now we start with the first talk, which is Anika's. Anika, the stage is yours.
Perfect. So welcome everybody to my talk, which is the title, It's All About the Data, because I want to talk a little bit more about the data side of AI. And since we decided to have a look at medical applications today, which is an interest of Abri and me, I will also give more examples in this application domain. So nowadays we have very much data in nearly all the fields you can imagine in industry and science. So environmental sciences, health, genetics, biology, population sciences, of course, in transport, so autonomous driving and so on. And all these data producers result in really a heavily growing amount of data. And luckily, today we can also process this data, since the computers have become very, very powerful, and we can really process very large amount of data. And I picked only a few data producers from the medical domain. For example, on clinicaltrials.gov, you can search for research studies, which are currently more than 360,000 in more than 170 countries. There are 19,000 hospitals, and all these hospitals produce data on their patients and analysis. We have really many physicians in Germany, and on a very famous publication platform, PubMed and Medline, you find millions of publications only for the biomedical and life science domain. So you see, these are only few examples on how much data is generated and how much data producers we have. And here we are on an AI convention, KI Wir, talk and discussion. And so I want to give a brief definition or introduction to remind what AI means. And I did, as maybe most of you would do if you want to understand a topic, you can Google it, and there you Google already uses a knowledge graph and really presents you very important information right on the top. And you see phrases like it's a simulation of human intelligence and machines, and you want to program to think like humans, and the machines should learn and solve problems. So very important AI components are the algorithms that can do reasoning and deduction, and machine learning. So not the human learning, but a machine learning algorithms. And we need lots of data to do this. And as a next step, I want to give some examples specifically for the domain of healthcare and medicine, how data could be used to have benefit for the most important aims, which are prevention, diagnosis, and therapy in medicine. So very important and huge field of AI in medicine is, of course, medical imaging. And I think in the next talk, we will hear a little bit more about this. So X-ray scans or CT scans can be evaluated by artificial intelligence algorithms. In particular, if you have really a lot of data, a lot of pictures, and then you might find diseased tissue and differentiate between healthy and diseased tissues. Or you could use electrocardiograms to find dysrhythmias in patients. Or what has also been done is to analyze the voice of patients or people who call the emergency to find signals that they might suffer from a heart attack. So you have some early diagnosis already. And a field that is of specific interest for me are more textual data, like electronic health records. So patients go to the doctor, and the doctor writes everything down at a computer nowadays, but sometimes they also write letters to other physicians and so on. So they generate a lot of documents about patients' health. And of course, there's a lot of literature, medical literature, biomedical literature, and you could use all this information to find co-occurrences or interactions, important connections that help you to improve the diagnosis and therapy, and to create recommendations that are really useful, maybe even better or often better than what you could find out manually. And another field of AI in healthcare I want to mention here is so-called chatbots or question answering systems. So one could imagine a machine that asks questions to a patient to describe the symptoms, or maybe in the hospital, hi, how are you today? And you can answer some questions, and this can help the doctors to do a fast anamnesis or monitor the condition of a patient. Okay, so these are some few some important use cases of AI in healthcare. And I want to think with you a little bit more how the data can help us here. So maybe we think about what the doctor is doing. The doctor makes a decision on a diagnosis or a therapy because he has really a lot of experience. So he studied medicine and knows about diseases and so on, but he has a lot of experience, and maybe he knows hundreds or thousands of cases from patients. And how can the AI make the decision? Okay, it uses really a lot of data, and it can, if it's designed well, and if you really collected massive amount of data, you might have 10,000 or 100,000 of cases, and maybe even can then perform better than physicians. So in medical imaging, for example, AI algorithms can perform really much better than single physicians to distinguish between healthy or diseased tissues. And of course, the AI cannot completely replace a doctor, but it can support the doctor. He can act faster, or she. And I will talk a lot about the benefits and risks later again. So how is the data used by AI algorithms? So then one very important field is machine learning. And I won't talk about really details of machine learning algorithms, but we have a look at the main workflow. So there are very important phases like the training and testing. And what we need to do machine learning is data. We have input data, and this data first needs to be separated in a training data and test data. Training data is used to run the machine learning algorithm, to create some model. And this model needs to be evaluated. Therefore, we need the test data, validate and improve the model, roughly spoken. So the output is a trained model, and this model is then used in production mode. So we will have a new data where we don't know the result, and then use this trained model to create some result. And this result might be some classification, like with healthy or diseased tissue, or which disease do we have here based on a combination of symptoms, or what might a good treatment be. And what is very important to always have in mind is that the result that we have here reflects the input data. So if we put garbage in, we might get garbage out, roughly spoken, okay? So we actually, the machine learning algorithm often is a black box for us, and we do not easily understand what's happening inside. It depends a little bit which algorithm it is, but it's really important to know the quality of the data that you put in is very important for your result quality. So what we need for medical AI is really lots of data. So I'm, as I said, more interested in the textual data part, like electronic health records, physician letters, laboratory reports, medical forms, so such case report forms that are used in clinical trials and so on. But many other media is also important, like, of course, the medical imaging, audio data, video data, and so on. And I want to summarize some important criteria of the data. The data should be clean. So data is not always perfectly useful. It can be unstructured, and this brings many problems for us. I will talk about this on the next slides. It should be correct. It should be representative and non-biased. So we should not have a systematic error in the data, which gives us also a wrong error-prone result. And what I think is really very important, we should work on connected data where relationships between objects from our world are made explicit. So we should work on graphs and networks. And our aim when we work with this data is to produce accurate, complete, and statistically significant results. So let's have a look at the workflow of data processing in general. I said we need massive amounts of data, and we want to combine data from different sources, and often we have semi or unstructured data. So we have this input of data and then nice analysis results, recommendations for the doctor, for example, on the output side. And this workflow looks like this for data science, AI applications, and so on. We need to acquire data that is useful, extract and clean the meaningful data, and we have to deal with errors or missing data and so on. And we have to integrate the data and enrich it, in particular if we have data from different data sources. Then the fun part that really a lot of people like is doing the analytics and machine learning and visualize the data. And then at the end, we interpret it. And the doctor, for example, can use it. And in my research, I'm focusing, I focused a lot on the data integration part, which is really, important part to have high quality and connected data. So we want to combine data. How do we do that? Yeah, we need to create links between objects from different data sources. And by integrating data from many different sources, we can really exploit the potential of data and possibly add more value and gain new insights. So this data integration idea is also important to have in mind when we talk about structuring the data and putting the data in a graph. So another field of research of mine are ontologies, or using ontologies for applications. I don't know how many of you heard about ontologies, so I will explain this a little bit because it's important to know how knowledge can be represented. So ontologies give us a structured representation of knowledge. Here you see some upper level of a simple anatomy ontology. So you have a body which has the parts head and legs and so on. And it is structured until the very fine-grained parts of the body. So it is a huge hierarchy and terminology consisting of semantic relationships, which have the semantics like is a or part of and even others. And each concept is well defined, and you can usually define domain ontologies, so to describe the knowledge of one domain. And then what you get out of this is a formal description, which is machine readable. So you can do reasoning. And what is a very simple example for reasoning? Okay, if you know A is equal to B is equal to C, then you also know A is equal to C. And the machine can use all these concepts and relationships between them to find out rules and find new connections or reason over the data. And in the medical and biological domain, just actually works very, very good because we already have really a lot of ontologies. So there are medical ontologies, gene ontology for the molecular biology, and Low Inc for laboratory data standard, and the medical unified medical language system. So we really have a lot of structured data available already. And these ontologies or knowledge graphs can then be used to help to structure our unstructured texts, like the patient records or doctors' letters. And we, what we need to do, or what we do research about, is entity linking methods. So we need to process natural language and create very effective and efficient matching algorithms. And I give you here a very small example, like a case report form. It asks, okay, we are looking to include in our study patients with established CRF as an indication for the treatment of anemia. So what is CRF? It could be very, very different things. Case report form itself could match here. And so this is some question a patient or proband of a study should answer. And if we want to combine this study data and the answers of the questions with other data, we need to understand this question, right? And here it's of course useful to identify the important parts of the sentences and annotate them with the ontological concepts, because those are well defined. They give us a graph structure, and then we can go on to process the data. And I want to show you that the matching and linking part is really a huge research area itself in the data management community. You can interconnect really different data sources, and people are doing research on the schema level. For example, you could have a German ontology and an English ontology. You need to find these relationships between the ontologies, which is a problem itself. Another thing is you might have textual data. You want to find similar elements in different documents. And then very important is this semantic annotation, where I showed you the example on the slide before, to link the entities in the documents with concepts of those ontologies. And imagine we can build a huge medical knowledge graph. This means we need to continuously reuse the already defined concepts and integrate new information and combine it with expert verification. So this is a strength of this approach, to say we do not take such only some free text. We really have verified knowledge, and this is also important input for machine learning algorithms and deduction in AI. So just one brief example how you could apply such a knowledge graph. You could, for example, then search for rules and patterns in the data, for instance, to find significant co-occurrences between the use of certain drugs and unwanted side effects. So you can take a lot of patient records, really millions, if you could get millions of them, and then find really unknown patterns co-occurring, drug effects, drug side effects, and so on. And this that can then help again for disease diagnosis and therapy development. To conclude for the talk, I pick out some AI challenges in healthcare that that are very important in this domain, but also in others. One huge problem before we can integrate the data is we have to exchange the data. This is unfortunately, from my perspective, a huge problem. So hospital A and hospital B cannot just exchange data due to good reasons, namely privacy, but it's really a problem. So as long as you cannot collect all this data to a big data pool, you can also not use it in the way I explained it. So we need to create platforms for data exchange that respect the privacy and integrate the data. And another part I did not talk about so much is the data is dynamic and the research is dynamic. So we have to continuously revise the data, the algorithms, our outcomes, and so on. Everything should be of high quality. This is always a prior aim because it's about the patient's health and so on. And it should be scalable and work in real time. You don't want to wait 10 minutes until the computer answers to your question. And the topic of next week is matching very well this point. Explainable AI is also very important because since the algorithms are becoming more and more complex, like deep neural networks, it becomes harder to understand why did the AI generate this result. You want more transparency and you want to understand what happened. And I mentioned the privacy. This is very important to find algorithms that take care of patients' privacy. And of course, we don't want biased models. The decision should be fair. This means we always need to have all important groups should be present in our data and be fairly represented. And this is also for the quality of the result very important. And another aspect, which is maybe sounds simple because natural language processing is already very highly developed field, but a cross-lingual AI in healthcare is also a huge challenge because there are languages that are not so widely used and highly supported. The ontologies have the best quality only in English. As soon as you go to some other language, quality of the ontology is much lower. So this is also a very important part. So you have really important benefits. We want better quality. We can have better quality of healthcare, more time for the patient, the doctor, but this support of the AI, doctor can have more time for the patient. We have improved diagnosis. For example, imagine people with rare diseases who would be lonely with their doctor, so to say, but in a big data pool, other people have this rare disease. This can really help. And you can also compensate poor health infrastructure to a certain degree. And on the risk and fear side, we have the protection of privacy. We have to have in mind automation can replace jobs, but I see it more as always a recommendation and support of medicine. And the bias in the data discrimination must be avoided. So what we actually want to develop to the best of our knowledge is a fair, explainable, privacy-preserving, but yet useful AI application. And the yet useful part is very important because, unfortunately, it's really hard to have everything at the same time. So the highest quality I have, if I have full support of all the data, then I can have really the best model. But this will not work because we need to also consider the privacy. And yeah, so to the best of our knowledge, I hope we will develop really useful AI applications, more AI applications for the medical domain. And this is my last slide with a small overview of myself and my research. And I thank you very much for your attention.
Thank you so much, Anika. That was great. Yeah, I think the conclusion is good. We need more AI applications, but they have to be privacy preserving and safe, secure, and explainable, and I think these are important topics for our discussion later today. But before we start, I would like to ask Abri to give your talk. Abri, a very warm welcome. The stage is yours.
All right. Hello, everyone. Just formally to introduce myself first. My full name is Johannes Abraham Coertze, and I'm from South Africa. So hence the JAC Design and Engineering. Currently, I am in a company called Link Health Technology, and I have been associated at Hochschule Anhalt in the biomedical engineering department, but I will be moving over more to the robotics and automation lab for the summer semester. I'm also currently doing my PhD in collaboration between Stellenbosch University and Hochschule Anhalt. All right. Right, so good old funny joke, right? The first program we all write in any space is the hello world. So artificial intelligence in medicine is experiencing its hello world state. It's becoming more and more popular, and it is quite a buzzword. How do we see AI in medicine? We basically see it as a need for automating tasks. And as Professor Anika mentioned, this helps in the clinician with their decision making, right? This also saves a lot of time, which then what a machine does not necessarily have is empathy, can be added in the healthcare. Just some fun facts about the market share at the moment. So 2 years ago, the value of AI in healthcare was 3.9 billion. It's estimated to reach $28 billion by 2025. When I was preparing for this talk, I created this mind map, and as you guys can see, it is a very cluttered, highly integrated field. And instead of going through the algorithms and discussing each of these terms, I was hoping that I could actually, with personal experience and projects that I've seen, debunk some of the fears that is created for AI in medicine. You know, basically say the Terminator, right? Okay, so if we look at machine learning, which is a part of AI, the first two types that are very popular at the moment is the mining of medical records. And the other one is the image analysis and classification. So both data sets, but in different applications, right? So for medical records, what is the reason for us to be working on medical records? Specifically, this is referred to as precision medicine. Okay, so not each one of us has exactly the same genome mapping or the same healthcare state or reaction to drugs. And this is where precision medicine is supposed to come in. How do we be able to do this is by mining the medical record. So as she said earlier, each medical record has a prognosis, diagnosis, and treatment plan stated on it. Unfortunately, all these medical records have different terminologies and packing, and that is where one of the pitfalls are, like she mentioned previously. Another part, so the advantages of being able to mine the medical records is that in future, we would be able to design treatment plans according to your health state. Also, health assistant in medication management, one of the applications that I saw, Alpha AI, I think was referred, is basically like a video. Someone's using their smartphone, and the smartphone camera detects them by showing the pull to the smartphone so that the pull is registered, and then they need to swallow this. And this is a pitfall that we have with patient care. Say, for example, in tuberculosis in South Africa, which is a big thing, what happens is drug-resistant tuberculosis created from patients diagnosed with TB, starting on the treatment and then stopping taking the medication because they're feeling sick and ill, and hence, or social stigma behind taking the medication, right? Augmented intelligence is also part of this. So doctors can see you for 15 minutes normally. When you go see a doctor, you're there for 15 minutes. They don't necessarily have all the medical history in front of them. But if we give them sample data about your history, they can make more informed decisions, because that is basically what a doctor does. Is they say you have your symptoms, they take the symptoms, they generate a hypothesis, and then they treat it. If you get healthy, then their hypothesis was correct. If you get sicker, they've made a mistake. And that is technically where AI can come in, is improving that hypothesis. And then finally, drug creation. As I said earlier, each one of us have different genome mappings and could hence react differently to the same drug. So if we have to treat a specific ailment, we can tailor that drug to your specific genome mapping. Right. As we stated earlier, also, there are some serious pitfalls in the mining of medical records. Firstly, the quality and the quantity of data, right? All of the data is in different forms, different spaces. We have to translate it as well into different languages. Secondly, privacy issues, right? Not every one of us wants to share our full medical history. There's also server hacking and worries about those type of things, like, for example, or how your data are shared, for example, with Facebook, right? Then thirdly, trust. So are you actually able in trusting a computer or artificial intelligence application to diagnose you properly? Because once again, there's that lack of empathy or human connection. Then finally, the biased AI, or second last, biased AI. And then finally, what I would like to refer to that is still a problem in medicine is the biological model. So in medicine, what is seen most often is that we just treat the effects and side effects. And this is basically the biological model. So that is where we as Link Health Technology want to come into this space. So from personal experiences as well, I realized that there are so many layers and factors that influence your state of health. In 1977, a model was created called the biopsychosocial model. So what does the biopsychosocial model refer to? It basically says that my health state is not just my biological state, but also my psychological and sociological state. So for instance, like I said, tuberculosis, or let's go with another implementation called depression. Depression actually biologically influences the amount of serotonin that my brain creates, right? That's a biological factor. On my psyche side, I have a very low self-view of myself. And then because of these 2 points, I remove myself from social settings. So the people that could actually provide me social support and make me feel better about myself, I remove myself from that. So if we could, by essence, scrape the medical data from your history, show that to your clinician, and on the other side, provide you with a tool to monitor yourself and basically show you what is the use of wearing something like a Fitbit and walking 20,000 steps, we could theoretically create a biopsychosocial model now with the modern technology. How would we really be using this in AI in this space is with machine learning. So basically the scraping of the medical data could be categorized as supervised learning, whereas the finding of algorithms or matching of inputs, because if we can say a certain person being treated a certain way has these certain markers, we can maybe find links between other patients, right? And hence change the treatment plan. And we could find this with unsupervised machine learning. Okay, right. That on big data sets. I would like to move to the second part of machine learning, which is image analysis and classifications. So here on the left, you can see I have basically showed the accepted process flow of a patient going through image-guided surgery process, right? So you would go visit the doctor would then send you to be scanned by either a CT scanner or an MRI machine, or you'd be undergoing an X-ray or ultrasound. Okay, that is what is referred to as image capture. in each of these steps, AI can actually be assisting, right? So for example, a very basic need in MRI machines, which are quite expensive, is when a patient moves during the MRI, your scan is basically faulty and you need to redo this. So this is maybe where machine learning can be implemented to firstly detect patient movement and then augment the data scan to allow for the patient movement. Okay, the second step, which is this image specifically on the right, is the visualization space. So after you've gone for your MRI or CT scan, you would that image would normally be sent to a radiologist. Now you can imagine with a CT scan, there, for example, of the thoracic area alone, it's got 5,000 different slides, right? From all the anatomical spaces. This means that this radiologist literally needs to go through each slide and specifically see whether there is a nodule or a cancerous item that can basically be seen as an imperfection, okay? So this is where machine learning can come in really helpful, is by detecting those shapes automatically. So that is called semantic segmentation, right? But now a radiologist in the terms of AI is also an annotator. So you have a data set being trained with previous people marking the nodules, but also we still need to confirm that that nodule or that marker that is detected with the AI is indeed the disease state. Hence, we won't be replacing the radiologist, we will just be making his or her life easier and more efficient, okay? This information is then sent, so after it's been visualized and that diagnosis has been sent, this is sent to your clinic. All this information for preoperative planning and basically diagnoses you and says, okay, we will, if there is a cancerous cell or imperfection, we need to step into surgery. And that is where my master's was specifically focused, was intraoperative guidance. Now, a big buzzword right now in intraoperative guidance is extended reality. So as seen here, the HoloLens, this was pretty much last week. So a surgeon was wearing in Brazil, I think, a HoloLens, and he was connected to several surgeons remotely in different locations, and they could basically talk to each other in real time to assist him with his decision-making process. This is also where AI can come in, because you have a video feed, you have a view of the patient. Automated expectations can be created from looking at cardiac arrest rates, or one thing that happens a lot in surgery is that stuff gets left behind when they close you up. So in America alone, I think there was like 6,000 cases of a sponge or a surgical piece left inside the body, which then means that they have to go back and remove that. Okay. I specifically looked with my master's into what is the feasibility of using extended reality currently in medicine. And that is where I did an analysis at the Grote Hospital and identified the need for AR in medicine. So as shown here, you have your surgeon being busy operating. For him to be able to see the image modality to guide him during the surgery, he constantly needs to look up and away from the surgical site, recreate all the coordinate points in his head, and then come back to adapt to the surgery. So that's also what is the buzzword for AR medicine, is the fact that I can have a holograph, what looks like a hologram in my field of view next to my surgical site. Okay, and that's what I built. I tested out how feasible it is to use the HoloLens in this space. So I quickly just want to show everyone this YouTube video, just so that everyone can actually see what I am talking about. So as you can see here, I am moving the shapes in place, trying to accurately place the virtual model of the skeleton onto the 3D printed hand of the same model. As you can see, manually, I can't do it that accurately. And that is where computer vision will come in, and as well as an improvement using SLAM, right? Okay, so that is the first part. So what I found when I did this study is that the SLAM settings, right? So the SLAM settings on the Microsoft actually loses as I plane from point A. So basically I set up a whole testing rig and I would move from point A here on the bottom, place my image on the, so this little square on the allocated space where it should be aligning my augmented view. I would then move from point A through a radius movement to point B. And basically you would find that there was what we call as holographic drift. Okay, so that is where AI once again can come in. And another thing that I found was if any object came into the space as I was moving, this would actually throw off my SLAM. So SLAM is standing for simultaneous localization and mapping off. So AI could be used to detect objects that can be ignored in updating of the SLAM. The second part, which I found that was also required, is that not only the doctors move during surgery, but the patients as well. So if you look at the bottom picture here, you can see that the picture on the left was at point A and the picture on the right was at point B. So as I moved around and the arm stayed the same, well, sorry, and as I moved around, the image stayed at the same place. But when I moved the arm, I lost alignment. That's where I basically try to use optical tracker. So if you guys, I can stop sharing so that I can just show you all of this. So this is a leap motion sensor. And basically what this guy does is an IR sensor that tracks my motions. So just to share my screen again. So that is how this works. So,
just a quick question. Sorry, I don't want to interrupt you for too long, but we have to keep in mind that our time is running.
Yes, I'm sorry. I realized that as well. Okay, so this is a kinematic model combined with a camera to detect and create computer vision, which in essence is a form of AI. Okay. Right, so I'll skip through that step then and talking about how that can be improved. But basically you can add more information in the AR space using computer vision by having annotations and adding labels to things what the doctor sees. Then finally, where I am going over at Hochschule Anhalt, we're looking at where a robot can become your friend. This is specifically focused around, in the case of someone struggling from dementia or where a nurse can't be with the patient 24/7, we could theoretically implement something like a robot to monitor the patient and send out distress calls if something happens. And that's where AI comes in. Then finally, just to summarize this whole space, as reminded by a colleague for me yesterday, machine learning or AI is basically a computer program is said to learn from experience E with respect to some class of task T and performance measure P. If its performance at task in T as measured by P improves with experience E. So basically we have a bunch of data sets. We have outputs that are required in medicine, and we can learn how to make those outputs better by using machine learning. And that's all for me. Yeah, that's me.
Great, thank you so much. It was really interesting and rich, and I think it was a great combination with the two of you. So let's start the discussion. So still people in the audience, if you have questions, please write your name into the chat or the question if you don't want to speak yourself. And I would like to start with the question, because both of you mentioned a few possible challenges with AI and medicine, and I think the biggest one is privacy versus you need tons of data, and you need to combine them in a way that they are not anonymous anymore. And this is a question for both of you. Is there a solution in sight for that challenge?
So the question is whether we can do privacy preserving AI. So we both said we really need a lot of data to support doctors in diagnosis, therapy, and so on, to come to recommendations and decisions. So the question is, can we combine this data by respecting the data, the patient's privacy? And one point is, for example, to do research how, for example, hospitals can exchange data without really exchanging like the patient's main personal data, like name and birth date. So this is possible. You could, there are even, there's research going on in matching different personal data, which is not plain text like the name, but you use like bit vectors or some other methods to not show the name, but you are still able to do a fuzzy matching to find out, okay, these are the same patients. I can combine the data. Maybe you can anonymously collect all this data. This is one point, and you need to take care that you don't show in statistics very small groups to preserve k anonymous results. So you should not say, okay, there was one person with this specific disease, and then I maybe know there was a person who took part in the study, and oh, I know this person had this disease. So this should not happen. You cannot publish such small specific cases. So yeah, so this is my answer. Do you have other ideas, Abi?
Well, for me, I think it's the ethical requirement of the enterprise offering the solution, right? To firstly act ethically with your data, but then also secondly, add the power in the hand of the patient. If we do data analysis, we don't need your name or your surname. We do need your date of birth so we can get your age, but we can, other than that, we can anonymize data completely. So for me, privacy in that space, I think we also have different viewpoints on privacy and what is required culturally in different spaces. But yeah, I think it's important to know how the organization intends to use your data. And then secondly, actually giving your consent to that organization to make use of your data. And if you have the power of your data in your hand and you choose to interact with that specific organization, I don't necessarily see a problem in the privacy realm.
Thank you so much. So I'm really happy that both of you are optimistic that there is a solution, or at least it doesn't. So privacy and precision medicine don't stop each other. I don't see any names or questions in the chat, so I guess I'll ask already a final one, which is if you look into the future, I think what I heard of both of you, if we are able to combine really large data sets, maybe ideally even everything we know about people's bodies, medicine, illnesses, and everything, if we combine that with augmented reality and things like that, Abri told us. So in theory, a doctor working with a patient and an AR headset, for example, could have all the knowledge from colleagues who are specialized in the topic and from the past.
Historical data. Yeah, like historical data. Basically, yeah. They have more data to make a hypothesis with, but the AI can also assist in actually making the correct hypothesis. So yeah. I think what excites me, preventive care instead of reactive care. So when we can start seeing that you are going to get sick, and basically before you get sick, we can help you, kind of thing. Yeah.
Yeah, I think that's one of the big promises, right? If you have all this knowledge, I think we really have to do things like this, help people not to get sick at all.
Prevention might also have a downside that you did not know you are sick, and then someone tells you are sick. Also, you did not feel bad. But I think we can really prevent or really do really early diagnosis and help people that you prevent to get the disease. Yeah. So what was actually a question?
The question was your vision for the future. So what do you think will the future look like? Is it really the doctor with the AR headset and having all the knowledge? And of course, what can we achieve with this? Will people be never sick? Will they get really, really old? Or what is the goal of the big picture?
So for me, it is also my doctor where I go to who has a computer that knows much more than it does now. This is so a short aim that you really have more of complete history of mine and combined with the history of others to have this better recommendations, and this would really help. And I hope we will have a solution to do so. For example, in Germany, it's not the case that this will happen tomorrow. And I hope that also from the side of government law and also from society that will have that it will have a good chance to help us. So, but I think in the mind of many people, it's still a problem. So to say, okay, I share all the data on my Krankenkarte, or how to say that?
Yeah, Krankenkarte, yeah.
No. Everybody knows who's living in Germany.
Yeah. Just to, from my side, conclude with what Professor Anika just said, I think once again, we have to, when we design technology, we have to take into account different users, right? One user might feel comfortable with sharing his or her data, and another patient might not. One patient might feel comfortable being diagnosed by a machine and having early diagnoses, where other patient might not. And that is very important to take into considerations. I think what I really like to see from being from South Africa and like knowing that there's like 1,000 people per one doctor, is just also helping the doctors get through patients, help support patients better, more holistically and concurrently. And then in general, just an improvement on quality of life. I don't think we always know what's wrong with us. And by having a system that can help you in understanding that information better, that is theoretically, I think, can just be beneficial. Yeah.
These are great points. Thanks a lot, especially that people can have a choice, right? So
Yeah.
there's one question from
and
the audience.
well, I want to add just I think this is, you're absolutely right, and this should hold for everyone on the planet, not only rich countries. I think this is also, but we have a better chance maybe with AI and technology that we can also help regions that have not this perfect structure. And yeah.
And there's a question from Vera Schindler-Zins in the chat, and she asks about the bias you mentioned as one of the pitfalls of AI in medicine. She asks, do you have any methods to mitigate that biases? I think that's maybe a big question because as far as I know, it's quite complicated, but researchers are working on that. Anika, you want to?
I think you have to work together with social sciences and sociology to really know how does your population look like, and then to compare if you reflect all groups, smaller groups, larger groups. This is very important. So, for example, if you set up a clinical trial and want to find out what are side effects of this drug, you need to consider easiest thing, men and women. So this is already not even always the case, and you should find this statistical distribution in the population and reflect this in your data set to avoid a bias as good as possible.
At least as a start. So since already some people are leaving, and I'm sorry to the last question in the chat, I think we have to come to an end because people have other plans for the afternoon. I would like to tell you what happens next, because this is a series of really interesting talks we have. So this Ringvorlesung, actually I don't know the English word for Ringvorlesung, but this lecture series will continue on March 12th with Frieder Stolzenburg of Hochschule Anhalt, and he's in the audience. And Frieder, would you like to just give us a short overview what you're going to talk about?
Yes, thank you. So the topic was already mentioned today. So I'm going to talk together with Francesca Schmidt about explainable AI and some problems we have with discrimination, and whether the explainable AI is a solution to the discrimination problem. I think we will discuss in March then.
Great, thank you so much. And I think this is really perfect, because this is, yeah, as we saw, a big question and big challenge in AI. So it perfectly fits to as a follow-up to this discussion today. And I can't wait to hear your talks and the talk of Francesca Schmidt, who is at the Gunda Werner Institute for Feminism and Gender Democracy. So we really have two really rich perspectives and views on that topic. Another quick announcement: there's a newsletter for the whole lecture series and the initiative, the KI conventions or AI convention. You can sign up on the website, so you never miss anything new and interesting. So you will find out as soon as there's the video online from this lecture, and maybe you want to send it to friends or watch some things again. And you will always hear about next events and everything. So if you want to, please sign up, go to the website to find more exciting events. And yeah, hopefully see you at March 12th for explainable AI.
Thank you.
Auf Wiedersehen.
Thank you very much.